आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
So hello friends, so we can write our equation or question as integral over 1 by sine to the power 4x plus cos to the power 4x into dx. Okay, so we are writing this as follows. Okay, so our question is can be written as integral over 1 by sine to the power 4x plus cos to the power 4x into dx. So in the denominator, multiply and divide by cos to the power 4x. It will be here multiplying, and then we are dividing it by cos to the power 4x sine to the power 4x by cos to the power 4x plus it will be divided by cos to the 4x, it will be 1 into dx, which can be written as sec to the power 4x integral over this will be tan to the power 4x plus 1 into dx. What we are doing here, we are applying substitution here. So see carefully the substitution part which I am applying here. So we can write here as tan x is equal to t. Okay, so we can take the derivative of that sec square x into dx, which is equal to dt. Okay, so we can write this here as can be written as sec square x into sec square x into dx divided by tan x to the power 4x plus 1. We can also write here as 1 plus tan square x. Sec square x can also be written as 1 plus tan square x, okay, dx divided by tan to the power 4x plus 1. We know that tan x is equal to t, and also know that simply we put that this part, okay, and also know that sec square x into dx is equal to dt. Okay, we are just putting these values, and what we can get, we can easily see here. So putting tan x is equal to t, we get here as 1 plus t square, here we get as dt, and here we get as 1 plus t to the power 4. Okay, this is our concept what we are getting. So take common t square from both the sides. So we are taking t square common from both the sides. So what we get here 1 plus 1 by t square into dt divided by t square plus 1 by t square. After taking common from this side, okay, we get this one. Okay, we get here t square, and here we get 1 by t square. Okay, so this is our equation. So now this t square get cancelled, so we get our equation as follows: 1 plus 1 by t square into dt divided by t square plus 1 by t square. Okay, now what we will do here, we will write our equation as follows. We can simply write this in the, we are now converting this in the perfect square form, in the form of a minus b or a plus b. So now we can see here it can be converted in the form a minus b whole square. Okay, so how can this be converted? So which I am converting here, I am just writing at, it can be written at 1 plus 1 by t square. How can this be 1 by t square? Means it should be minus 2 into a into b, means this when we get multiplied, this get multiplied t into t square into 1 by t square. Since minus 2 is done, so we have to add plus 2. This to this t square will cancel, so this can be written as, this can easily be written as t square. So it can easily be written as, t minus 2. Okay, so I can write it here as t minus 2, t minus 2. Okay, no, it cannot be written as t minus 2. It can easily be written as, let it be written as what I am writing here. See carefully, because you have to provide your 100% concentration. T minus 1 by t whole square plus 2. This would be your concept. Okay, so now what I am doing here, we are writing this in the denominator. Okay, so our denominator part is clear now. So denominator is integral over 1 plus 1 by t square divided by t minus 1 by t whole square plus 2 into dt. Okay, so Now what we are doing here, we are applying here substitution. Okay, let t minus 1 by t is equal to v. Okay, so after derivation, what we can do it, we take the derivative of this one. So after taking this derivative, what we will get 1 plus 1 by t ka square, which will be equal to multiplied by dt, which is equal to dv. Okay, so putting this all these values here and this value here, we get here as this 1 plus t square, 1 by t ka square, it will be written as complete, be written as dv, and this one t minus v can be written as t minus 1 by t ka whole square can be written as v square. It can be completely written as plus 2. Okay, it can be written as 2, so it can also be written as dv divided by v square plus root 2 ka whole square. Okay, so now what we are doing here, we are just writing our answer as follows. We are making further modifications. Okay, so we know one formula, that integral over dv by v square plus a square can be written as 1 by a tan inverse v by a plus c can be written as. So using this formula here, for dv here, a is equal to root 2 v square plus root 2 whole square can be written as 1 by root 2 tan inverse v by root 2 plus c. Now here what happens here, we know that v is equal to we have assumed as t minus 1 by 2, and also t equal to tan x. Here we have assumed as t is equal to tan x, so this can be written as tan x minus 1 by tan x, which is equal to tan square x minus 1 by tan x. Okay, so now what happens? Here, we can write it as follows. Okay, we can simply put here value of v in this final equation, which will be equal to root 2 tan inverse, and we get our answer tan square x plus 1 divided by root 2 tan x. Okay, so this can be easily be done by our simple easiest method. Okay, so here we have find the answer, but this is tan square x minus 1, so our answer will be here. It will be can be written as tan square x minus 1 into this is our plus c is the constant of integration, so this will be our answer for this equation.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।